Hello friends, so we've come to the second episode of weekly doubt clearing session. So in this session, as you know, I will be taking doubts from the previous week and I will be trying to clear them in a video so that all of you can see what are the doubts being asked in the videos. Okay, so it will be benefit for everybody. So the first doubt is asked by Kramer.Mund. I think I am pronouncing it wrongly. So if you can just tell me what is the correct pronunciation. Anyway, the doubt that he has asked is very interesting. So what he is asking is that what is the difference between the round rotor and a synchronous motor? Means a rotor of the synchronous motor. Can we make the round rotor a synchronous motor by using a DC source on the field? Okay, see the basic difference between the wound rotor and the synchronous motor, right? So in the wound rotor, you are not giving any separate excitation. Okay, whereas in the synchronous synchronous motor's rotor, you are giving a DC field as an excitation and the wound rotor is found in a synchronous motor. Now you are asking whether we can make the wound rotor a synchronous motor by using a DC source on the field. Now that is a very, it depends on a lot of parameters. Now as I've told you, in a synchronous motor, we arrange the windings. For example, you are using a distributed winding. You make the windings in such a way that the field on the rotor resembles a sinusoid, right? It should be a sinusoid in space. Therefore, in this area you put maximum conductors, here less conductors and less conductors and so on. Okay, so we have derived a small expression also for this. So if this condition is met, yes, you can use it. But another thing is that the wound rotor construction is very different. So you don't intermix all these things. Okay, so that is the first thing you have to understand. Synchronous motors are made as synchronous motors. The induction motors are made as induction motors. The thing is, the wound rotor, you are having 3 rotor windings. Of course, we will discuss them in detail in the later part of the course. You are having 3 windings on the rotor. Okay, so they are connected like this, and the other parts are connected to the slip rings like this. Okay, so it is connected to slip rings. So this is brought here, and this is brought here. Okay, so you have brushes also. So these are the 3 slip rings, and from here you are having terminals here. So when you run the motor, what they do is that they short out this. So this is the connection that is used. In case for starting of induction motors, etc., they can add a resistor here so that they can improve the characteristics of the induction motor while using a wound rotor. Okay, so they are made differently. You don't have to intermix all these things. Yeah. So I hope that is clear. The next doubt is asked by Mr. Shivakumar. He is asking, why rotor is rotating less than synchronous speed? Why is rotor rotating same direction as in stator field? Why not opposite to the stator field in case of motoring mode? Please give me the clarification. This means you have not watched the previous video. Okay, you have directly watched this video because in the induction motor second video, we are discussing induced torque. Okay, induced torque in the induction motor. So in that video, all these doubts are cleared. I think I mentioned in the comments, replied also for this. So you please watch the video number 2. In case you are having any more doubts, please put them in the comments below. Okay, so I hope that is clear. Yeah, Asha is telling, will you please start from basics of electrical? It is very useful for us in other competitive exams. Now, Asha, one thing that you have to understand, as an electrical engineer, this is a thing which most of the universities do wrong. Specifically, the government universities that you find. For electrical engineers also, they have a course on basic electrical engineering, which is not supposed to be. If you see big institutes like IIT, etc., the first year itself, they are brought to core courses of electrical engineering, like engineering circuit analysis or maybe machines, DC machines, a full course on DC machines. But in some of the syllabuses that I have seen, in the first year, they have basic electrical engineering course for electrical engineers also, for computer science engineers also, for civil engineers also. So for computer engineers and civil engineers, okay, you can just do a little bit, you can touch upon the grazing of the surface. But when electrical engineers are going to learn all these things in the future courses, why to just brush them up with things? No, that is not how it happens. So if you are asking for basics of electrical, basically I think you are asking for the Kirchhoff's laws or 3-phase circuits, etc. That is part of engineering circuit analysis, which is already present in this course. And other than that, machines, induction machines, or DC machines, that is also available in this course. So as such, to boil them down to a simple very small course called Basic Electrical Engineering actually is an injustice which is done to the subject. And as electrical engineers, you don't need any basics of electrical engineering course. You have to directly deal with the subject. I hope I am clear now. Okay, so that is why there is no separate course on basics of electrical, because all these things are basic things only. There is nothing advanced in understanding slip speed or slip of the induction motor. Kramer Dortmund has come again. He has asked another interesting doubt. So thank you, sir. Can you tell us who decided the percentage of slip? For instance, if you have two motors, one motor is slip 3% and other is 5%. Does it depend on the construction or motor or what? Now, that is basically up to the designer actually. See, the full load slip, okay, slip speed at full load. Slip speed at full load will be equal to the synchronous speed minus the speed of the motor at full load, right? So this is set by the designer based on the requirement which is given by the user. So naturally, when you have fixed this value, naturally the slip speed at full load also will be fixed. So this is basically at the time of design they will fix how much they all want all these things. So I hope that is clear. Now Hubayb Khan has asked a question. This is an old course on engineering circuit analysis. Shouldn't be there a negative sign with the current and then further change in power calculation? Explain please. Okay, so this is why I ask you to put timestamps in the video. Now this video is around 15 minutes long and I have discussed multiple numericals here. So when you ask a doubt like this, I don't know from which area you are asking. So if you had put a time stamp below, I would have gone more accurately. So anyway, just assuming that you have asked for the first question, so I'll just revisit my KVL also for a bit. So basically, how do you do this problem? So you have to find the power absorbed in each element. So you have to find the voltage and current across each element. Okay, so what do you do? So my way of doing is introducing a current value I, arbitrary current value and arbitrary direction, and introducing a movement. Okay, so you are going to move in this direction. Okay, you are going to move in this direction, and in this direction you are going to write the KVL starting from this point and ending at this point. So if you write the KVL here, you see in the 30 ohm resistor, my movement and the current movement is the same direction. So plus 30I. Okay. From here I am entering a positive 2 VA plus 2 VA. And here you see it is minus. The question itself they have given a minus here. Don't go and change that. So here I am entering a negative sign. So minus VA. Okay. And then from here I am entering a minus 12 volt. Okay. So this is equal to this value. So 30I plus VA minus 12 equal to 0. Okay, so you have an equation with two unknowns. So now we have to try to find a relation here between VA and I. So this current I is going to flow here. So we'll just take that resistor to the other side. So this value is 15 ohms. Okay. So this is minus plus VA already defined. So based on this current value and as per Ohm's law, we know that the voltage drop will have the polarity like this. So this will be 15I. Right, the voltage drop will have this polarity according to Ohm's law. But somehow in the problem they have defined it like this. So you should not change this. So the relationship between this 15I and this VA is that VA is equal to minus 15I. Because see, plus is connected to the minus, minus is connected to plus. So VA is equal to minus 15I. So if you substitute that value here, I will get 30 minus 15I minus, so this is not 12, this is 120. Okay. So this is 120, this is also 120. So minus 120 equal to 0. So that means I value here I have got it to be 8 amperes. Right? I value I have got it to be 8 amperes. So to find the power absorbed, what you do? So you take the first element here. And so the current value you can take it this itself. So don't change the current value also. Current direction. So this is I which is equal to 8 amperes. In case you have got a minus value also here. So don't go and change the current direction and you will screw up the entire question. Just follow the passive sign conventions and you will get the correct answer. So this is I is equal to 8 ampere in this direction. This is 120 volt. So they have asked the power absorbed, right? So we have to write the power absorbed. So power absorbed here, you can see that the current is coming out of the positive terminal, which means that power generated will be positive. But they have asked power absorbed. So if power generated is positive, power absorbed will be negative. So minus, what is the voltage? 120 into 8. So this is minus 960 watts. Okay. For this resistor, if you see, so this current is 8 amperes. This is 30 ohms. Okay, so the power absorbed by the resistor is always positive. So plus I square R. So 8 square into 30 ohms. Okay. Similarly, for this also you can find that the current is entering the positive terminal. Therefore, for this element, power absorbed will be positive. So the power absorbed will be equal to plus. Outside I am putting plus just to show that the power absorbed is positive. Plus 2 VA into the current value which is 8. Okay, and VA is equal to minus 15i, right? VA is equal to minus 15i. So that you can substitute here. So you will get 2 into minus 15i into 8. So this will be equal to 2 into minus 15 into 8 into 8. Okay, so this is the way you can do all these questions. Okay, so I think this resistor element I don't have to do, you can do it on your own. So this is how basically you do all these power absorbed questions. Okay, so I hope that is clear now. Shubha Banerjee has asked some things here. Sir, please discuss induction harmonic torques, synchronous harmonic torques, cogging, crawling, transient responses, etc. All these will come in the future sessions of the course. The course has just begun. There is a long way to go before we start induction harmonic torques. Okay, but anyway, surely I will cover these things. Okay, Shubha. Anudeep Kumar, sir, please do a video on Scott connection on transformer. Nobody is explaining clearly about. Now, in my last video on transformers, I have already told you there are 3 topics which I have left open to you. One is open delta connection, one is this Scott connection, and another connection I don't remember which one. Other than that, almost the entire concept of transformer is covered. And this is one thing that I usually do, that I explain a lot of things, but 1 or 2 concepts I will leave it up to you. Because then only you will take your own effort in understanding this. Otherwise, the problem is that you will always depend on someone in making you understand certain things. And that is not good for your future. In the future, when you come into the industry, there is nobody who is going to come and teach you everything. So you have to do some things on your own. So that is why some of the topics wantedly I leave it to you. And these are not very difficult topics. If you have understood the course so far, understanding this will be very easy. And once you do that on your own, your knowledge will be permanent. That knowledge will never go out of your mind. So that is why you have to do some things on your own. Okay. Rajat Gupta asks, what is the significance of the flickering frequency? So this is based on the synchronizing procedure. But I don't know, I cannot understand this question actually. What is the significance of flickering frequency? Based on that flickering frequency only, you turn on the paralleling switch or you turn off the paralleling switch. So I am not able to actually understand the question. You go through this video once again. There are 4 videos on parallel operation of alternators in which I have dealt one video specifically to this flickering frequency. Okay. So just go through that video and then you will understand things more clearly. Rajat Gupta, one more doubt he has asked. Tell me that why you have taken EA value at no load, but we have to find VT at 0.8 lagging, means load is connected. Then EA not change when load is connected. Okay, so this is also something I am now getting a little bit confused. I think in this numerical, the question was to find VT at 0.8 lagging, and you had to find, for that you had to find EA at no load, right? See, EA is a function of K phi omega. Okay, so this will be constant throughout. It is only depending upon the flux and it is only dependent upon the speed. So that is why you do that. Other than that, I am not able to understand what is the question. It is a simple numerical, just using some KVL and finding what is VT at 0.8 power factor lag. Okay. Vinay is asking one question. You said by increasing generator frequency, active power generation from the generator would increase. But doesn't that much increase in generator frequency cause effects such as more flickering in the lamp case? What is the value to which the generator should increase so as to maintain the parallel operation? See, I have never told that you have to increase the generator frequency to increase the active power output. The concept is not like that. To increase active power output, you should increase the mechanical input or the torque input to the generator. That is the correct concept. But while doing that, sometimes what happens is that, see, the speed of the motor might little bit rise. But when generators are in parallel operation, the other generator will automatically add reactive power to the system and make the other system slower. Okay, so whenever you want to adjust active power, you adjust the mechanical input, not adjust the frequency. Remember that. So anyway, you go through these videos once again, then I think you will have a more clear idea in which I am explaining about parallel operation with infinite bus bar and parallel operation of 2 generators also. So you see that video and you will understand about the house diagrams, etc. So you have to watch those videos properly, you will understand the concept. So remember, active power generation adjustment is torque input or mechanical input adjustment, and reactive power adjustment is field current adjustment. Okay. Mercedes Benz, it's an interesting name. He's telling me, I really appreciate your lectures in the playlist parallel operation of alternators. For that I have 2 questions. Do you have any recommended books and material concerning the topic? The second one is that is it possible to do another lecture about parallel operation of alternators which show the effect of load sharing and primer? Okay, now this books, in the sense I follow Chapman, but other than Chapman also I refer some other books or multiple books I refer to understand a particular topic. But basically the course structure is usually from the Chapman book. Next thing is that he's asking me to do some videos on effect of load sharing, prime mover. This is already available in the concept of synchronous generators, already available. All these topics are already available. I have given a reply also. Next question. Yeah, Kwaku Bini. This is also, please tell me the correct pronunciation. Why V5 leading is greater than V5 lagging when EA is constant? I didn't get it. See, V5 leading means you are V5 during leading. Okay, so V5 during a leading condition, it means that the load is the capacitive load, and a capacitive load produces reactive power. And whenever you add reactive power to the system, the voltage will rise. When you absorb reactive power system, the voltage will drop. That is the basic concept. So because it's a capacitive load, for the same EA value, on the load side, the voltage will increase because the capacitor bank or the capacitive load will supply reactive power at the load side. So therefore, the voltage at the load side will increase. Another way of understanding this is that for the same V5 value, for a leading load, EA required will be less as compared to EA required for a lagging load. Okay, so that is another way of understanding. I've explained all these things very clearly in those videos. Anand Gupta is asking a question. Sir, torque induced opposes torque applied. But here we see there is no much difference in that magnitude. Of course, there will be no much difference in the magnitude. That is correct. See, torque balancing means, for example, you have a motor. You are having a demand. Okay, load torque demand is there. So the motor will generate only that much amount of torque which can drive the load. Okay, it will not produce more. If it produces more torque, it will accelerate. If it produces less torque, it will decelerate. But for a steady state speed for a motor, for example, the load torque should exactly balance with the induced torque. The meaning of that is that, for example, the load torque is 20 Newton meter. The motor also will produce exactly 20 Newton meter for steady state operation, constant speed operation. Okay, so I hope that is clear. Yeah, now that was all the technical doubts. Now let me spend some time for people who have appreciated these videos. So Afsar Hussain is a regular viewer of the viewer. He has appreciated the video. Thank you. Hafiz Mohammed has told, thanks a lot bro. Found it very informative. Very glad to help you. Irfan has told, eagerly waiting for this series. Yeah. So I hope you are enjoying the series. We have covered almost 3 topics now and more topics will come. Shailendra Yadav has told, excellently explained sir, but I am shocked on the very less views. Yeah, views does not matter for me much. But in case you want to help, you can definitely share these videos with anybody who is interested in all these topics. Thank you Shailendra Yadav. Krishna Dutt. Don't know why lesser views. I was searching this content for a long time. This video is only having the content. This was related to harmonics of transformers. So I'm happy that you finally found out the video and you are able to gain some knowledge out of it. Bajirao Kulkarni tells, thank you sir. Thank you Bajirao. I'm very glad to help you. Abhishek Gautam, good. Thank you. Shubha Banerjee has said, superb sir. Thank you Shubha. Asha is telling, sir, very good job you have done. You are covering each and every topic and each concept. Keep it up. Thank you Asha. Very nice to hear comments from all of you people. Vasanta Kumar is telling, you are my inspiration sir. Thank you Vasanta Kumar. I am glad you are taking me as an inspiration. Tech Geek is telling, good work Varun sir. Your videos are quite extensive, intriguing and very helpful. Keep up the good work and don't be discouraged. We support your work. There is no point of being discouraged here, right? This is my passion. Teaching you all of you is my passion. So therefore there is no concept of getting discouraged. Okay, so thank you anyway up to showing your concern. Adam is telling, the way you put things together is amazing. Please upload some power system videos. Currently I am going with a DC machine. DC machines course is a very extensive course. I am very happy that you are selected my course because it is going to be a very useful course for you. Power systems, as of now, there is no plan to cover power systems because I am going to do mainly induction motors now. Maybe after that some other simpler subject, because machines itself has taken a lot of time for me. Almost 1 or 2 years it is taking to cover the entire machines. And as such, power system is just a marriage between engineering circuit analysis and electrical machines. So if you understand these 2 subjects, understanding power systems is not a difficult thing. Sai Kumar has told, thanks sir. Nikhil Hanotia has told, thank you for the course, really helpful. Okay, so I thank all of you who have spent your time appreciating these videos. In case I missed someone, sorry for that, and I appreciate all of your concerns. The next thing is very important now. Many comments are coming regarding numericals to the course. Some of you are asking me to do numericals from a particular book. Some of you are asking to do only numericals. See, one thing you have to understand is that there are some subjects which you have to use numericals to make you understand the concept. For example, engineering circuit analysis. If you see that course, the theory portion is very less. For example, 1 lecture or 2 lecture will be on theory portions, but maybe 10 videos will be on numerical, because that is how you understand the subject. But a subject like electrical machines is not understood purely by numericals. Of course, I can do simple trivial numericals and just show that I am going to do a lot of numericals. But you should understand one thing here. If you have gone through the course properly, some numericals I just put in between the theory. Those are simple numericals, so that I can just give you understanding on how these equations are coming up. But there are some specific numericals which I dedicate a lot of time in making. For example, in DC machines, there are some numericals which are 4 lectures long, each lecture being around 10 or 15 minutes. That means 60 minutes for a numerical. Those numericals are very, very good numericals, very conceptual numericals taken from very, very good books. So once you understand those numericals, doing other simpler numericals will be a piece of cake for you. So please go through those numericals. It is not the quantity which matters in understanding electrical engineering. It is the quality what you are going to do. Okay, so that is one important thing. Just for the sake of that, I can just put out a lot of numericals. That is not the thing. Another thing is that there is a time concern also, because if I simply spend a lot of time on numericals, I will never be able to cover the subjects which I want to do. Because as of all of you know, I am having a full-time job also. But that is not the reason for all these things. The actual reason is that, see, for a competitive exam, when you are preparing for a competitive exam, not competitive exam also, even in your life, as an engineer's life, if you are going to see these numericals being worked out by someone else, and then you are thinking that you are going to understand the numericals, you are doing a big mistake. Of course, 1 or 2 videos you can watch on numericals, but the bulk of the work of solving numericals has to be done by yourself. That is how you train your mind in attacking problems which come in engineering. Numericals are the best way so that you get out of your comfort zone and you try to tackle a problem even without knowing what might be the solution. So that is the importance of numericals. And if you are going to prepare for a competitive exam simply by looking at videos by somebody who is showing you solving numericals, you are not going to train your brain. You have to do numericals on your own. 1 or 2 videos you can watch from here or there, or some worked out examples you can see, but the bulk of the work of solving numericals has to be done by you. Because once you solve that one numerical on your own, the concept will be etched inside your mind. You will never forget that concept. So keep that in mind. Numericals you have to do on your own. That is very, very important. Of course, for some subjects like transformers, I have done a lot of numericals because there's a lot of variety of numericals which can be asked in transformers. So therefore, I have spent a lot of time in numericals. But a subject like synchronous generators, more than numericals, it is a theory part which is very, very conceptual. And I have to spend more time on that. So I hope you are understanding me. Always do the numericals on your own. Because for example, tomorrow you join an industry, and for myself, my boss asked me to design some circuit or make a logic to solve some problem in my industry. I will never find some videos on that, or I will never find some books written on it. I have to do that from my own experience and my own ideas and my own concept, and the idea should come from my mind. And if I am able to do that now, it is because I have worked in solving all these problems earlier in my student life or when I was preparing for the competitive exams. Okay, so that is why I am able to do that now. If that point of time I had not trained my mind to tackle all these things, maybe now I will not be able to do that. So remember, as an engineer, you should study like an engineer. You should study, you should train your mind in solving problems. Okay, so I hope things are clear. There is another one question where a lot of people asked me, I don't know if they are even watching the videos. The first question they ask is that, are these lectures helpful for GATE? That I will explain in another video. Okay, so people who are watching these videos, attending the course, I think you already know the answer, whether these videos are helpful or not. But for the others, I will definitely make a video on that and I will touch up on some topics. Okay, so I hope you have liked this video and I will see you in the next video. Thank you. Now that the video is over, please stay with me for 30 more seconds. Now the vision of this channel is to create a repository of good quality videos with crystal clear explanation regarding various topics related to electrical engineering. Now if you want to help me spread the word, please share this video with anyone interested in these topics. The second thing is that for me, education is a two-way process. Therefore, if you have any doubts or suggestions regarding any of the videos or regarding the channel, please put them in the comments below. We can have a healthy discussion, and that way we can build a strong community of electrical engineers. So that's it for today's video. So till I see you in the next time, it's me Varun signing off, and have a great day. Thank you.